Now let us see what is a quasi-static process. See, quasi-static process, you can see that initially this is a piston cylinder assembly. These are all gas molecules. Okay, this is the initial state. Okay. So when you measure the pressure here, it has 10 bar. Here also the pressure is 10 bar. This is a pressure gauge. Now the piston is moved suddenly. Okay. So initially, let us move that the piston is moved very slowly. So you can see that the gas, since it is moving very slowly, the gas here doesn't get compressed faster than the gas here. So if you measure the pressure, you can see that it is 20 bar throughout. PA is equal to PP. That is the intermediate state. And this is called quasi-static compression. But let us see what actually happens. So here also you can see that if the piston is compressed very fast, if the piston is compressed very fast, so if you measure the pressure here near to this piston, you have high pressure, that is 40 bar. Here you have low pressure, that is 20 bar. Because when the piston is moved very fast, the gas near here, see, you can see that the gas near here gets compressed more fast, higher, gets compressed higher than the gas here, because the piston is moving very fast. So the effect will not reach here all of a sudden. So when you measure the pressure here, the pressure will be higher, here the pressure will be low. Okay, so PA will be less than PP. So this is called a non-quasi-static compression. That is a normal compression. Okay. In a quasi-static compression, that means we are compressing very slowly. That means there is no unbalanced pressure throughout the system. Everywhere the pressure is same. So this can be achieved only if you compress extremely slowly. Normal cases, in normal compression, it will always be non-quasi-static compression. Okay, so you can see that when you are compressing in a quasi-static compression, only when the properties are same throughout, we have already seen that only the property, only if the system is in equilibrium, then only you can fix the state of the system. Otherwise you cannot fix the state. So here you cannot fix the state of a system through any intermediate state, because throughout the pressure will be different. It is not in mechanical equilibrium. There is lack of mechanical equilibrium, so you cannot fix the state of the system. Okay, so how you can show that in this diagram? There is a pressure volume diagram. So initial state was here. That means initial state was here. Okay, so when you compress, final state will be here. So intermediate states will be these dotted lines, these dots. These are the dots. So but these intermediate states can be determined only if there is that is throughout in equilibrium. So you can draw this solid line only if it is follows a quasi-static process. Otherwise uh, it can be shown by a dotted line, because you don't know the intermediate states. You are not sure about the intermediate states. That's why we are using dotted line. But if this is a quasi-static process, then it is doesn't have any problem. That means you can surely draw this solid line, because all the intermediate states can be easily determined. So this is here the dotted line is for a non-quasi-static process. We are showing the dotted line because you don't know the intermediate state. You are not sure about the intermediate state.